feeding into in a closed sort of circuit, fermentation vats. Okay, and they're all of the same volume, 100 gallons, fermentation vats connected as indicated. The mixtures in each tank are kept uniform somehow. In each tank, in each individual tank, the concentration is uniform, okay, but maybe different from tank to tank. Denote by x sub I t, and that indexing x sub I, they're just being lazy. Instead of saying x1, x2, x3 of t, they're just saying denote x sub I of t, the amount in tank t sub I. When I is 1, 2, 3, and they knock them all out. So they define it that way. Suppose that the mixture circulates between tanks at a rate of 10 gallons per minute with the arrows shown. So for instance, T1 is not feeding into both T2 and T3, it's feeding into T2 but being fed by tank 3. Okay? But all that's moving around at 10 gallons per minute, so that keeps the volume in each tank constant, right? We know that. And it says derive those equations. And they put all that weird spacing in there because it's going to start to hopefully remind you of a matrix, entries in a matrix. So let's do that. Let's just talk about tank 1 individually. So that's the key to these guys, is take tank 1 individually. And we would say, I guess, dx1 dt, right? The rate of change of the volume in tank 1, not volume, amount of salt in tank 1 at time t. This is what they call x prime. We're using t as the independent variable. Okay? So we got rate in minus rate out. And at what rate is I guess it's alcohol, it's fermenting, right? So at what rate is the mixture entering tank 1? Right, 10 gallons per minute, but that's not 10 gallons of salt per minute, that's 10 gallons of whatever it is, beer. 10 gallons of solution, okay? But then the concentration of that solution, we don't know how many pounds per minute of solution is entering. That depends on its concentration. So 10 gallons per minute of a concentration of what?
We don't know.
Well, it's coming from tank 3, and we're calling the amount of salt in tank 3 x sub 3, right? And how much volume is in tank 3? 100 gallons. We got x sub 3 pounds of salt per 100 gallons coming in at 10 gallons per minute, right? And what's the rate out? And it's going into tank 2. What's the rate out? Still 10 gallons. Oh, just to put the units up here, this is pounds per gallon. Okay. And the rate out? Exiting tank 1 at 10 gallons per minute still. At what concentration? Leaving tank 1. So the concentration in tank 1, x sub 1 over is still 100 gallons. So this is pounds per gallon again. All right, and from here on out, I'm just going to write it like this. I'm going to leave off the units. That's the unit analysis. We get pounds per minute. That's what we're talking about, the rate of change of x. So this would simplify a little bit as well. 10x3 over 100, or x sub 3 over 10, minus gallons, we got pounds per minute again, and it's going to be x1 over 10, right? Okay. So let's do the same thing for tank 2. And this would be rate of change of the amount of salt in tank 2, dx2 dt. Oh, by the way, this should be x1 prime, right? Yeah, these are all subscripted. But x1, x2, and x3 all represent variable functions, variable quantities over time. And so this one will be, we'll call it x2 prime. And let's do the same thing, rate in minus rate out, tank 2. 10 gallons a minute, I'm going to leave off the units this time. Coming in 10 gallons per minute. at a concentration of, it's coming in from tank 1, x1 over 100. All right, rate in minus rate out. This is going to be another 10 because it's flowing out at 10 gallons per minute, but it has a concentration of x2 over 100. That's the concentration, so the amount of salt in tank 2. So that's the subscript there. So here we get x1 over 10 minus x2 over 10. And let's do the same thing with the third tank. dx3 over dt. That's what we're calling x sub 3 prime. All right, so same thing. Rate in 10 gallons a minute at a concentration of x sub 2 over 100 minus rate out from tank 3, 10 gallons a minute. So these all start to look the same. I just got to keep track of which tank it's flowing to and what's flowing into that tank. So this is what? Yeah. Right, flowing out of tank 3, so that's x sub 3 over 100. So this gives us x2 over 10 minus x sub 3 over 10. All right, so we got equations. I'm just going to call them 1, 2, 3. And if we multiply all those equations by 10, both sides, what do we get? First equation, multiply both sides by 10 to clear the fractions. I'll have 10 x1 prime equals x3 minus x1. Right? Equation 2, multiply both sides by 10, we're going to have 10x2 prime equals x1 minus x2. And equation 3 will be 10x sub 3 prime equals x2 minus x3. Now, why do they have it all spacey in the book? That's the system right there. They're just writing it so that they're putting spaces, and they're doing it in order so that I have all x1s in the first column. It would be x1, negative x1, right? Plus 0x2 plus x sub 3. Okay? This one, if I arrange it that way, I got x sub 1 minus 1x sub 2 plus 0x sub 3. I'm just putting the zeros in there. They don't have them in the book. And this is 0x sub 1s plus 1x sub 2 minus x sub 3. And that's why they put it in the way they have it. These are just going to become slots where I put the coefficients. 0, negative 1, 1, 1, 0, negative 1. In the book, they didn't write these zero terms. Right?
Multiply 3 by 10.
Why? To make it look like the one in the book. See the left side are 10s. They got rid of the fractions and wrote it like that. It's just as good. Yeah. If we were going to do this really through by matrix, which we're going to start to do, we'd leave x1, x2, x3 prime and put the coefficients over there. We'd see those 1/10s. Okay? In what we call a coefficient matrix.
It wouldn't really matter though, would it?
No.
Like,
Well,
you could have
no.
your,
You could have
other
10.
side is- yeah. Equal stuff.
Yeah. Yeah. All right. Oh, any other questions? I feel like with some of these problems, we got time for 3 and a little bit of new stuff before it's time to roll out. What I wanted to do first, though, at the end of the last class, I passed out a sheet on matrix, some matrix operations and practice and things like that. I want to go over a couple of those together, just to reinforce those before we launch into new things like eigenvectors and eigenvalues. All right, so it looks like this. 5.1 matrices. That's the front side, n by n matrix. It defines what that is. What I want to look at is on the back side, 2 by 2 matrix. They talk about the determinant. Oh, there's a 3 by 3 matrix. And we can find its determinant as well. We've done some of that. More complicated, we've done determinants of the Wronskian matrix of functions. This works the same way, but these are luckily just real number entries. But what I want to look at is, on the back side, a couple of these guys. All right. So starting with number 2 on the back side. All right, up here in number 1 on those are all 2 by 2 matrices except for X. This is what's called a column vector or something. And it's literally just a vector, but instead of written sideways, it's written as a column. Same way they work. It depends, they work the same way, it depends on if you're in a Calc 4 class or a linear algebra class. That's all. All right. So let's look at number 2. It says, write the system in this form. Okay? And this P of T is going to represent a matrix. Now, this P of T can be confusing. It could be a matrix of function in each entry, but it could also be a matrix of constants. Okay, so another way to write this, X, and if it's in bold in the book, they don't use this notation, but I usually put a little bar over it because I can't do everything bold and unbold, by hand. But X prime equals, and oftentimes they just use A as a matrix. Okay? All right, where that column vector X represents X1, X2. Okay? So let's take this first one in part A and write this in that form. So writing it vertically helps because X1 prime is negative 3X2. X2 prime is 3X1. Okay? And it might help to put those missing values in here. So like I did on the board, X1 prime is actually 0X1 minus 3X2. And X sub 2 prime, 3X1 plus 3X1 plus 0X2. Right. All I got is 3X1, so it's 0X2. Okay? Now that is the result, that looks like the result of matrix multiplication to me. What matrix would be multiplied by, in this case, the X1, X2? 0X1 minus 3X2. So 0 minus 3. This is why matrix multiplication is defined the way it is. And that second line looks like 3 times X1 plus 0X2, so my coefficients here would be just 3 and 0. Okay? Okay. So that is our matrix A that I was referring to up there. So what we got is, in matrix form, right, it would be, X1, X2 prime. You don't see this notation much, but the derivatives over there equals 0, negative 3, 3, 0 times X1, X2. Okay? Or for shorthand, that's just our X prime vector equals a X column vector. Okay? So we found that matrix. It just amounts to finding this matrix and knowing that if I multiply a 2 by 2 matrix by a column vector, it's this form, 0x1 minus 3x2. That gives me the first equation. X1 prime equals 0x1 minus 3x2. X2 prime equals 3x1 plus 0x2. Okay. 0x2. All right, what about, so try the one in B.